have Aditya Sen speaking on the topic shrinking production incidents. He's traveled around 45 countries in the world and aims to travel every one of them to cover actually the whole world. One of incident that he remembers that he was actually stuck on an island for over a night in Bolivia because he had missed a ferry. But today he's on time, so please give him a big round of applause.
Yeah, okay. So this talk is about shrinking production incidents. If you've read your lanyard, it actually says shrinking production incidents. So if you're looking for that talk, this is not it. So what I'm about to talk to you here today is how do we keep outages from affecting your users. So a bit of background, whenever you go to a talk, most people wonder, why should I give my 45 minutes to this person? So just a bit of background. I work for Google in Sydney. I've been an SRE for over 6 years now, and I've spent the last 2 years with Google Cloud. During my time as an SRE, I've spent most of my time dealing with outages or incidents. Some people call them outages, production incidents, what have you. And I've learned quite a few things, so I'm going to try to go through some of them in this talk today. So it's important to understand why we want to minimize production incidents. So reliability is always the key indicator for any service. If your service is reliable, your users are happy. If your services are unreliable, users are unhappy. But the key is, if your service is always reliable, user happiness doesn't go up. Users just become indifferent to your service. So you could be reliable, you could be very reliable, your end user wouldn't know the difference. But if you drop in reliability, that's when users get annoyed. So user happiness is important, and we're going to try and map this across the graph. Your service has a level of reliability. Let's say the blue part is where your service is healthy, the red part is your service is unhealthy, and this is your service healthiness measured over time. Does anyone know what this graph would be called? Or what the line between the blue and red is? It's your SLO, or service level objective, right? So if you go above the SLO graph and your service stays up, your users become indifferent, right? So it's not like you're ever going to stop having problems, but on average, if you're above in the blue line, users don't care. Now, say this is a user happiness graph for your application. It could be a website, a chat app, pick something that you run. So we're starting off in the nice blue region, everything's running fine, users are happy, and right here we have an outage. Now this could be any number of things. Your users can't access your application, maybe you pushed a bad release, maybe you have a machine failure, something's gone wrong, you have an outage. Now, ideally you have someone on call for the service, either your DevOps, SRE, dev, whoever, and once enough errors have accumulated, you get an alert which fires. Now, this is the point where someone who is responsible for the service realizes that there's a problem with the service, right? So you act the page that you get, whatever, you now head to a computer and you try and solve the problem. So eventually, as this happens, from the time the alert fires to the time you try and fix the problem, your user happiness starts trending down. And now you're in the red, which means users notice that there's a problem with your service. So you want to have users to have the best experience, so eventually you find out what the problem is, maybe you do a rollback, and you fix the issue. Slowly, now you start trending back up again, users start getting happy again. Right? Now, eventually, sometime in the future, you're going to have another outage. This is, we'd like to say there are no outages, but eventually you'll have an outage. And over there, your next outage begins, your user happiness trends down again. So you can break this graph into 3 parts. The first is the time to detect, from when there's actually something gone wrong to when an alert fires and someone realizes there's a problem. The longer that takes, that affects the slope of the graph, right? The next is the time to repair, from the time someone has acknowledged that there's a problem to the time the issue has been fixed. And the last part, this is the one you want to maximize, is the time between failures. So you want to shrink the time to detect, you want to shrink the time to repair, but you want to maximize the time between failures, right? And that would keep your users out of the red zone. So let's try and break those down into how would you invest in improving each of those three phases. So 3 is always the magic number. So the first one is you create SLOs. SLOs, service level objectives. These should be the basis for your error budgets. Now, error budgets are a whole different topic in themselves, but they should define how measurable your service is. And when I mean measurable, it's whether your service is actually affecting users, not whether machines are having a problem. The second thing you need to do is write postmortems. How many of you write postmortems in your team when you have an outage? That's great. So when should you write a postmortem? You should write a postmortem after every incident, but you should also write a postmortem if you get lucky. So say, for example, you had some issues with your service and you never actually burnt your error budget, and you still stayed in the blue. You should still write a postmortem because this time you got lucky, and you might not get lucky the next time, right? And you should write a postmortem so next time, even if the same incident occurs the next time, the postmortem should outline how could things be better the next time. And you should record all the incident data, which is what led to the outage, what did everyone do during the outage, and how did you resolve the problem. And finally, you should have a blameless culture. This is, in my opinion, the most important part about managing an incident. Because the last thing you want is your on-call person to worry about, am I going to get fired for doing something? Or, am I going to get into trouble? Or do I need permission to do this? So if you promote blameless culture, that is the most important thing that gives your on-callers the freedom to actually fix the problem and not have to worry about keeping their job or protecting their co-workers' jobs. So, you shouldn't be focusing on what people are doing, you should be focusing on what the system is doing. So, 3 things: create SLOs, write postmortems, and promote blameless culture. And lastly, the blameless culture enables honesty, because then you again, like I said, you're not worried about what you're doing to keep your job, because you did the best you could with the tools you had at the time. Okay, so now you've got your SLOs, and you know if you need to shrink the time to detect to keep your users happy. You've got blameless postmortems, so now you know where you need to shrink, because you can go back and look at what happened to keep your users happy. Now, nothing that I mentioned here so far is super revolutionary. Most of you working in teams already know about all of this, right? So even if you don't have a system where you have good SLOs defined, you don't have a system where you write postmortems, right? You don't have a completely blameless culture. All the stuff that follows here is still relevant. You can use the next few slides as a checklist to assess where your service currently sits. So let's go back to this graph and focus on the first part, which is how do we shrink the time to detect an incident? So as the person on call for the service, you can't even start work on mitigating a problem if you don't know that the problem is happening, right? You don't want your first postmortem to say something like, the service died, no one knew, we lost a lot of money. So we have 3 rules for shrinking the time to detect an incident. The first one is improve your SLI signal, which is your service level indicator. Now, you know whether there's a problem with your service based on your SLI. A good SLI moves up if users are happy and moves down if it affects the user, right? So you should only measure things that you want to alert on. We had a this open spaces discussion just now about how do you know how much monitoring is good enough. Like, you can measure CPU utilization, you can measure error rates, but what does that translate for the user? Does it mean that, if I have a higher CPU utilization, my users see more errors? If yes, then you should alert on that. If not, probably not. Start with something simple. This is an iterative process. There's no silver bullet here where I define these alerts, it's going to be perfect. So start with something simple, and then keep iterating to make it better. Next, you need to keep your readings fresh. So this means you should get an alert, ideally, before your service catches on fire, right? So before Google, I worked for another company where most of the alerts were log-based. They would analyze logs and try and work out if something is broken. The problem with this is latency, obviously, because you're introducing a delay and you don't get real-time alerts. So they switched to streaming in-memory alerts, where it was a push-based system rather than a polling system, and that definitely reduces your latency. And you want, so I just said streaming, and then lastly, you want to create effective alerts, right? So what does it mean for an alert to be effective? They have to be user-focused, they have to be sensitive and actionable, and they have to be delivered appropriately. Okay, so I can go through each one of those. User-focused alerts, as I just said, is you want an alert to fire only when your users are being affected, right? If you alert too quickly, for sensitive and actionable, if you alert too quickly, you can introduce on-caller fatigue. Like, you don't want to be alerted or paged for something at 1 a.m., you wake up and the problem's gone away. But you also don't want to alert too late because you're probably going to burn all your error budget. So it's hard to find the right balance, and the right balance depends on your service, but it's something that you need to iterate and work on. And finally, the alert has to go to the right person. Now, if you're in a small team, you're in a small company, that may not be a problem because probably the service is being handled by a small group of people. But if you have more than one on-call team and who manage different aspects of the service, you want to make sure that the right people are alerted for the service. And finally, the most important one, which a lot of people tend to forget, is you have to make it loud. Use a pager service. Use something like PagerDuty. Use, I think, VictorOps. So there are plenty of things out there. Do not use email. Because email works maybe if the person's sitting at the desk on a weekday, but what about the weekend, right? What about you're on call on a weekend and you get an email saying something's wrong and you're in the shower? How many of you read your email in the shower? Right? So if you get to these three things, you'll minimize your time to detect an incident. Now, shrinking the incident is a little harder, mostly because the first part in reducing the time to detect is a technical thing. You can improve your alerting, you can tune some metrics and go from there. But this section here is mostly about policies, politics, people management, and stress management, right? Even if you detect early and your alert fires at the right time, your on-call person gets notified, is it any use if all you do is panic? So this is, in my opinion at least, the most important section to focus on. So also, before we go ahead, the most important thing as an on-caller is to protect the user. Your main job when you receive an alert or receive something that says service is dying is not to fix the problem, it's to mitigate the problem. A lot of people spend time trying to debug the code base, let me push another release, let me try and fix things. No. The first thing you should do is roll back, get your service to a state where it's healthy again, and then look at fixing the problem. So, what can you do to improve the time to repair? First thing, train the responders, right? You have to have emergency procedures that are defined and tested. A lot of teams have emergency procedures defined, but the persons responsible for actioning these have never gone through them. So you need training. And don't just train the people on call. Train your dev teams, train the CEO, train anyone who might be involved in the incident. right? To keep it fresh, run failure drills. At Google, we call this wheels of misfortune, where we pretend there's an outage. We get everyone in a room. You pick someone at random. They get voluntold that you know how to fix this. And they have to run through the scenario of if it was an actual incident, what would they do? And this doesn't have to be something super complicated. It just can be something simple like users are trying to access the site. They get this error. What would you do? And then you try and work through it. And then you hold practical disaster recovery tests. So this is where you engineer a real outage on your service, not a pretend one, and you try and mitigate it. Okay? So this, apart from training, this also tests your escalation channels. So another thing we run at Google for disaster recovery tests is every year we pretend that San Francisco has been attacked by Godzilla or has an earthquake, and we try and respond to see what would we do. Can the company still keep running? Can we still remain, can we keep our services healthy? Second, you need to write useful run books. Some people call these playbooks, alert books, run books, call it what you like. What this is per alert, you need to have some sort of documentation that says, if you get this alert or you get this page, here's what you need to do, right? You need to write things, it has to provide decent clues to investigation, and it doesn't have to be very detailed, but it should have enough clues in there so that your responder knows, once they get this alert, where should they go? What dashboards to look at? What logs queries can I run? Because you can't expect everyone to hold that information in your head, right? And keep it simple. So you don't want a run book that says, click on this link, enter this graph. Just keep it simple, so to say, if you're getting this alert, look for these clues. That'll tell you what's going wrong, right? Another problem with writing run books is people keep it where it's written in a way no one else can understand. So it should be written for a version of yourself that's just come back from holiday and you forget what you do at your company anymore. It should be written for that person so that you see the first time, you can still follow it. And this is a good opportunity for a failure drill. So when you actually run your failure drill or a disaster recovery test, you go through your run book. Was there anything in there that your on-caller had to do that wasn't in the run book? Add it in there. Was there information in there that was too complicated to follow? Simplify it, right? Next, you need to set your pager response expectations. This is a little tricky because it depends on your service, depends on your team. But the first one is, from the time I receive an alert or a page, how long should it be before I start working on it? There's an obvious answer here. Most people will go, well, right away. You've got an alert, you should start working on it right away. Again, it's fine if you're in the office on a weekday, but what about the weekend? You can set a 5-minute SLO to say, you need to be at your desk in 5 minutes from receiving the alert, but is that practical? Does that mean that the person on the weekend just is always within 5 minutes of a computer? So there's a trade-off here. 30 minutes is generally a decent SLO, and that's what most teams at Google run with, but then again, you have to alert quicker so that by 30 minutes, you're not burning your error budget. So there's a balance here. Basically, this is jumpiness factor. How jumpy does your on-call need to be once you receive an alert, right? And you don't want that jumpiness factor to be too high. In the same theme, you need to reduce responder fatigue. Because on-call fatigue is a real thing. Like most of us probably know this, is you don't want to get paged or alerted for an incident that you just push a button and it goes away, right? So we call this eliminating toil, where you can automate most of these things. So for instance, if you know release management, how much of your release process can you eliminate by just automating something? You can get more people on the rotation, right? This sounds like a simple thing, but you might go, but I only have 4 people on my team. Well, get people from other teams. At Google, we have a rule of there must be at minimum 6 people on a rotation for it to be an on-call rotation. What if you don't have 6 people in your team? Well, then another team covers for you. Because responder fatigue is real, and you want your on-callers to be happy, because at the end, it comes down to people being happy, right? Finally, you need to get rid of unactionable alerts. If you get an alert that says, I don't know, CPU utilization's gone up, but you end up doing nothing with it, well, just get rid of the alert. Like somebody asked earlier in one of the other talks is, how do I know how much to monitor? Start by monitoring everything, and if you find things aren't useful, stop monitoring them, right? Or you could relax your SLOs. These SLOs could be, you could have a really high SLO that you're trying to meet, but if it doesn't translate to your users actually experiencing something bad, well, your SLOs are too high, right? You need to trim these. There's more. You need to empower your responders, right? This is more of a political thing than a technical thing, which is you should give your on-call technical and political authority during an outage, right? You don't want your on-caller to have to ask somebody senior for permission to do something. If you're on call, you're in charge and you have the authority. On the flip side, you need strong audit logging, because being blameless does not being invisible, right? You still need to be accountable for your actions. Another way to improve your response time, improve your recovery tools. Say, for example, you got alerted again for an incident, you know what to do, you did it within the right time, within 30 seconds you've run your tool, but what if that tool took half an hour to run to mitigate the problem? You've lost all the benefits you've got. So you need to improve your recovery tools. And you need to have fast rollbacks, because going back to my earlier point, your main goal here should be to mitigate, not to fix. So the first thing we generally tend to do is, if there was a new version out and it's causing a problem, go back to the old version and have automated failovers. This is, again, depends on the scale of your service, but if you notice that there's an outage, you shouldn't need a human responder to go and flip it to a healthy service. You can use health checks and automate your failovers. Finally, you need good monitoring. Visual time series graphs, I think most of you already know this. You need good internal metrics. These are not the metrics you alert on, but these are the metrics you look at when there's an outage, so you can dig deeper into what's going on. And you need good logging. Your logging needs, the right level of error details. Now, logging is also tricky because logging can be expensive. Do you log too much? It might not be useful. You're spending most of your time filtering through things. Your cost goes up. So don't try to log too much. Again, this is an iterative process. You need to trim to work out what you need. And with logging, as most of you know, user privacy is important. You probably have legal teams to figure this part out. Don't log passwords. All right, so you've mitigated the outage, okay? Your users are rebuilding confidence in your service, you're going back into the blue. Now you want to increase the time it takes before your service fails again. Like, we don't like to think the service would never fail again, but it will. So at Google, we found most of the time we have an outage is because we've had a new release. Something's been pushed out. So the simple solution is, well, let's just stop releasing. The longer we don't release, the longer it'll take for something to fail, right? It might work for a little while, and sometimes it's not a bad idea. For example, if there's this one weekend in the year where your service makes 100% of its revenue, don't release during that weekend. That's a simple answer. But you don't want to stop releases forever because there's always features to push, bugs to fix, whatever. However, you can make the changes safer. So what happens if you go too long between an outage? It sounds great for your service because I haven't had an outage in a while, but there's a trade-off there. Your on-callers lose practice, right? Now, if it's been 3 months since your service last failed and your on-caller gets an alert, sure, you have these run books, you've done your drills, whatever, but they've gone, what was that again? Last I looked at it was 3 months ago, right? You've lost all the benefits again. Now you've gone too long between your outages. Your on-caller, if they would have normally taken 5 minutes to fix the problem, now takes half an hour. Well, you've lost all your benefits, right? So in general, it's better to focus on shrinking the time to detect and time to repair rather than trying to optimize for this. So as good as that is, most of us don't really have the problem of too few outages. So let's look at what we can do to maximize this time. The first one, as I mentioned before, you need to write blameless postmortems, right? There should be one written after every incident, and you need to analyze what can you do to make things better the next time. If the outage still occurs the next time, well, at least you have a history of what things could have been done to improve it, right? You need to write collaboratively. Everyone who was involved in the outage, whether it's the person from support who received a call, to the person who debugged the issue, to the person who pushed the fix, everyone needs to contribute to their postmortem. That way you get a perspective from all sides. And this one most of you know is CI/CD, continuous integration, continuous delivery. This is how you can deploy changes with reasonable confidence that it won't blow up, because if you are down the CI/CD track, when you do a release, they are small. That way your problems are smaller and your rollbacks are smaller, right? You wait too long, your problems get bigger. Have good testing environments. At Google, you can't submit a single change unless all tests pass, and you can't submit a change without a test, right? So these are just checks in place. It's not that none of us want to submit code without tests, but if these checks are in place, it just enforces good practice. And one of the most important things we found about CI/CD is gradual rollouts. Roll out to 10% of your users, roll out to one region, roll out to certain versions of your app. That way, if you do have a problem, you're only affecting a subset of your users. And this would also flatten that sadness slope that we saw on the graph earlier. And this one sort of filters back outside of DevOps into your dev side as well, because your code and your data have to be forward and backward compatible. Because this is probably not news to anyone, but when you're doing a release, 50% of your service is running on version X, 50% is running on version Y, so now you need your code to work on both versions of the system, right? Next, you need to build a robust service architecture. What makes an architecture robust? The architecture is robust if it continues to serve your users even if you have failures. This sort of means is you have redundancy. So you're having an issue, and there are no single points of failure, right? And you have graceful degradation, which is, there's a big difference between my users can't use my service as opposed to my users have a bad experience with the service. A bad experience is still bad, but it's better than no service, right? Finally, this is not a term I like, chaos engineering. Some of you might have heard of it. I prefer to call it resilience engineering, but it's useful. I alluded to automated disaster recovery testing. This is, you instigate a real outage. You break things in your system in a controlled fashion and try and see if your system can recover automatically without human intervention. What should you expect when your system breaks in this controlled manner? Nothing. Your users shouldn't notice, your on-callers shouldn't notice, and you should get to that point, right? So, these are the things we covered today, and if you want a stack rank of what are the most important things you should focus on, well, I would say ignore everything at your own peril. You should focus on all of these at some aspects. If I were to pick the top two, it would be have SLOs that relate to user happiness, to your service health, and have a blameless culture that promotes writing postmortems in a healthy way and doesn't blame the on-caller, but gives people the freedom to fix the problem. Happy to take any questions as well. Thanks.
Any questions?
Hi, Aditya. So, in one of the slides, you were talking about the logs, right? I mean,
yeah.
Again, question to similar on, or a follow-up question to someone asked us, like, how much should we measure, right? I mean, or how much should we monitor? So, looking at the situation, right, when we have logs, so do you train the machine to say that, I mean, today if I have a situation where one particular issue comes in multiple times, should I focus on that, and tomorrow, once it is in a better or probably in a blue situation, then should I move to the next issue that comes across? Should I train my machine to only look at those logs instead of monitoring the entire thing or getting the entire log data? So is there anything that you guys are doing?
I think logs should be used as a measure of not trying to work out what's going on now, but what happened in the past, right? So if you're trying to, work out which log should I look at, that should be after the fact. If you should be measuring what's affecting my service right now, and what logs do I need to work out what's going on. And that's an iterative process. It depends on your service, it depends on your system. There is no simple answer as to, look at these logs first. If it completely depends on the service you're trying to measure.
So this is more towards, again, related to the earlier session also, where people are trying to have too much of logs, right? I mean,
yep.
And how do you ensure that we don't monitor everything? I mean, monitor only that is required. So where do you decide which one should I monitor? Or how do I use the predictive analysis to see that is there anything that is working towards it?
I know a lot of us try to think about machine learning and predictive analysis, but it's not a silver bullet, it's not a simple answer. What we've actually found is, for the most part, if you run disaster recovery tests or simulated incidents, that's when you can go back and look at your logs and say, okay, these logs were useful and these logs weren't. And you use that process to work out, okay, I can probably stop logging these things, right? And then you do that multiple times, and it's over the course of your, quarters, years, months. It's something that takes time to develop. There's no simple answer, unfortunately.
Thank you.
Yeah, one thing I had was
Yeah.
that see, the time to repair is the most important thing, as you also mentioned, and
Yes.
everybody struggles in that area.
Yeah.
So do you have some run books which you have developed across?
Yes.
Now, there may be incidents which have occurred earlier.
Yes.
How do you really make sure that you don't discover this thing out, and what is the mechanism in place that you've got across to reuse the incident fix that you used earlier, maybe 2 years before or 3 years before? How do you quickly search that and time to repair is faster?
There's two things here. One is, if you've had an incident before and you've had your postmortem, you probably should have action items from there to fix this. So you shouldn't be seeing that incident again, right? If you've done your due diligence and you've gone back and fixed things. But if I understand correctly, you're asking how do you discover something that's happened before?
It's a repeat of what happened earlier.
It's a repeat of what happened earlier.
Now you want to fix it fast. So you want to discover from your repository.
Yeah.
The same
So
incident.
that's where you go back and update your run books. So what we do is, if you've received an incident and it caused to this problem, once you've fixed it, you mitigated it, one of the action items from your postmortem should be go back to the run book and add that as a note in there, that if this alert fires, this is probably going to happen. That's one way to go for it.
Hi, great presentation. Thank
Yep.
you for sharing. So the point about postmortems, writing the postmortems, and also the keeping the updated run books.
Yep,
I find that to be the most challenging.
it is.
Right? Are there any? Do you have any inputs on, like, how do you coach to cultivate that habits into a team?
So this is a problem everywhere. Like, once the issue is finished, things are stable, people want to go back to the shiny things of building new features and, don't go back. So what we generally have is we have fix-it weeks, where we have all these issues that have come up as action items from postmortems, and everyone stops working on features, on whatever you have, and all you do for the entire week is go back and work on action items from postmortem. This is, again, like I said, this part is more of a cultural thing rather than a technical solution, right? Because you might have the best solutions in the world, you might have the best tools, but if you don't have the culture around going back and reviewing postmortems, that's another thing we do. So we have something called post-mortem reading clubs, where we read a post-mortem from another team, see how they handled the incident. Did they come up with the right action items? And you do this across teams. If you're a small team, just do it for your team. Go back, what were the postmortems we did a year ago? Because you probably have new people now. Do they know how to respond to that? That's sort of how you go about it. Yeah.
Just a quick thought. SRE will be very successful after 1 or 2 years, right? Because if it's a new application or entirely new setup, you may not have the error data, or you would have not established SRE culture at all, right?
Yep.
So any thoughts on that? Or
I think SRE is not a silo in itself. It's collaboration between your devs and SRE. So generally, you should try and establish your SRE working with the dev during the product development cycle itself. Not once the product's out there, oh, we need an SRE team to help us manage this. That's too late. You should be thinking about this from day one when someone's thinking about a new feature, a new application, what have you. That's when you need to start establishing SRE culture. Because it generally takes about a year or two to get your product out there. And in that year or two, if you've had an SRE team working alongside with your dev team, then by the 2 years, you're probably in a better state than you would have been before. Yeah.
So, over here. So,
yep.
Nice speech. So, my question actually resonates on the previous question. So, at Google, do you have some kind of an indexing on the runbooks so that the time to detect and the time to resolve the incident is minimized?
What do you mean by indexing?
Like there would be, let's say there are 100 runbooks for 100 different types of incidents or alerts.
Yep.
So the responder should know which runbook to fetch immediately, so that even that time is reduced. At Google, do you have some sort of?
Yeah, so where we do it internally is every time the on-caller receives an alert, the alert actually includes a link to the runbook you should be reading. Because you should always have one runbook per alert. So whatever your notification system is, knows what the alert is, you can probably include a link to your runbook there as well.
Hey, Aditya.
Yeah.
Priyadarshan here. So how do you correlate DevOps and SRE roles?
That's always a difficult question. I don't think so. I think SRE is an implementation of DevOps. It's like if DevOps is the superset, SRE is a subset of DevOps. Because SRE mostly focuses on just keeping the system running and doesn't really get involved too much into the product development cycle. So that's the way I see it, at least.
So can we say that in previous era we were calling the system admins the ops, so they are becoming the SREs?
Sorry, I didn't hear that.
I mean, in previous decade we were having system administrators, right?
Yeah.
So are we calling them SREs, or they are becoming SREs, or what? How do you define them?
I don't know if I'm qualified to answer that question. Yes, I guess some SREs are sysadmins, some sysadmins are SREs. There's definitely a very, very large overlap. But I think sysadmins focus more on the aspects of keeping your service healthy, while SRE looks at more from the perspective of SLOs and error budgets and things like that. So that's the way I see it, at least.
Thank you very much.
Cheers.
Let me put that question straight.
Yep.
So in Google, do you have like SRE and DevOps separate teams, or all together?
No.
Okay.
No. We have dev teams and we have SRE teams.
No,
That's
DevOps.
it. No DevOps, no.
So just one SRE team which just takes care of the DevOps.
Yep.
As well. Okay. Thanks.
So one last one. So do you think SRE, in your view, do you think SRE needs a functional knowledge of the flow of business, how functionally it flows? Do you think it is an important thing for him, or he can just, for an SRE, it is just a machine, it is just a system that needs to be operated on or mitigated? Yeah,
the second one, it's just a system. So I'm an SRE for a product called Cloud Firestore. I have no idea how Firestore works. It's just another distributed system, right? Previously, I was an SRE on the networking team. So there's a level of abstraction. If you're an SRE, you'll just look at everything as a system. Packets go from here to there. Sure, once you actually come to the point where some internals are failing, we escalate to the devs. And I think that's sort of a difference between SRE and DevOps, where we treat everything as a black box and we try and keep that running.
Okay, I guess that's it for the questions. Q&A round. Thank you so much, Aditya. It was a wonderful presentation and talk.